And let's say that we have h of x equals 2x minus the cubed root of 3x squared, just to make it look complex. And my interval will be from -1 to 3. So I could write it, I'm going to write it a little bit differently, but I could say candidates for absolute, extrema, maxes and mins, are endpoints which include x equals -1 and 3, or critical numbers. And we're going to see if we can find some critical numbers. So I come back over to my h of x, and I'm going to take the derivative. So first thing I'm going to do is actually rewrite this. So I'm going to say h of x equals 2x minus, and then this is a 3x that's squared to the 1/3 power. So this 3x is really to the 2/3 power. So 3x to the 2/3. So when I do the derivative, I'll have h prime of x equals, the derivative of 2x is just 2, minus, and this is the chain rule, u substitution, so this is a u to the 2/3, so I'm going to take the derivative, multiply the 2/3 down, keep my inside function the way it looks, subtract 1, so -1/3, times the derivative of the inside, my u prime, so times 3. To clean this up a little bit, I can see that this 3 and this 3 cancel out. This 2 will be in the numerator. This 3x will be in the denominator because of the negative exponent. It's to the first power, but we're taking the cubed root. So my h prime of x equals 2 minus, and then I'll have 2 divided by the cubed root of 3x. So I want to figure out what are the critical numbers, and there are two places you look for critical numbers. You want to know when the derivative is equal to 0, so I could set this equal to 0, and I want to know when the derivative is undefined. Now, for it to be undefined, you're looking for like the square root of a negative or a divide by 0, so we have that happening right here. So at x equals 0, this denominator would be 0, which would make your derivative undefined. So one critical number would be x equals 0. Now you do want to go check your original function and make sure that your original function is defined at x equals 0, and it is, because 2 times 0 is 0 minus, and then this would be 0 as well. So I know that there's actually a point at 0, it's 0, 0. So the next thing I'm going to do is actually set this equal to 0. So 2 minus 2 over the cube root of 3x equals 0. And then don't make this hard and start worrying about how to actually solve this. Most things can be done either through factoring or multiplying, and we can handle denominators by getting rid of them, but what I'm going to do first is isolate this. So I'm going to add it to the other side. So 2 equals 2 over the cube root of 3x, and you might see some things that you can do right now, but I really just want to show you that this pretty much works every time. If you cross multiply, which is the same thing as just multiplying this denominator up to the top, I have 2 times the cube root of 3x equals 2 times 1. 2 times 1, not 21. So this is a 2, which I can now divide both sides by a 2. That cancels and that cancels, so I know the cube root of 3x equals 1. I can cube both sides, so 3x equals 1. And then I divide by 3, so x equals 1/3. So another critical number is x equals 1/3. So to finish my candidates test, I'm going to plug the 2 endpoints and the 2 critical numbers into my original function. The one that gives me the highest value will be the max, the one that gives me the lowest value will be the min. So I want to know what is h of -1, and I'm going to do them in order. You don't have to. What is h of 0? What is h of 1/3? And what is h of 3? So let's start with this negative 1. So 2 times negative 1 is a negative 2, minus, and then I plug my negative 1 in. Negative 1 times 3 is negative 3 squared is 9. So I'm going to say minus the cube root of 9. And what I know right away is that that is a negative number. If I have to actually figure out what it's approximately equal to, we can do that. H of 0. I take my 0 and plug it in. We already did this once, but it's 2 times 0 is 0, and then 3 times 0 is 0. To all of those exponents is still 0, so this is 0. So if I stopped right now, this would be my min because it's negative. This would be my max because it's not negative. It's more than a negative. It's 0. If I take my 1/3 and plug it in, that would be 2 times 1/3 is 2/3 minus 3 times 1/3 is 1 squared is still 1. The cube root of 1 is 1. So 2/3 minus 1, and that equals a negative 1/3. So now I have two negatives to compare, but this one is negative 2 and then take away the cube root of 9. This one's only negative 1/3. So before I even subtracted more, this one was already smaller. So this is still my min, this is still my max. This one just doesn't matter at all. So I take my 3 and plug it in. 2 times 3 is 6 minus the cube root of, and then 3 times 3 is 9, squared is 81, and I have the cube root of 81, which people get stuck with, and there are other approaches to take, but I wanted to take this moment to just show you how you could actually factor this out. I need to know if this is a positive or a negative number. If this is negative, I'm subtracting a negative, and that would make this entire thing positive. If it's a positive number, I need to know about how big this is. So one thing you can do is do a factor tree just to see, does that simplify? So we'll take 81, and that is 9 times 9. So 3 times 3, and then a 3 times 3. So I know that this is really, there are 3 3s, so I can pull a 3 out. So this 6 is 6 minus 3 times the cube root of 3. And I would have to know the size of this. Now I know that this is, that's interesting that I was talking about this being positive or negative. It's negative. It's very much, this whole thing is negative. This is positive. But this right here, I want to know, is it more than 0 or less than 0? What's going on there? So really, how is this in comparison to 6? So is this number more than 6 or less than 6? So one other thing you can do is actually just to get the size of this thing, like what is 2 cubed? You know, what is 3 cubed? What is 4 cubed? What is 5 cubed? And that gives you an idea. So 2 cubed is 8. This is the cube root of 81, so I know it's more than 2. 3 cubed is 27. So I know that this right here is more than 27, so it's more than 3. 4 cubed, 4 times 4 is 16 times 4 is 64, so this is more than 4. 5 cubed is 125. Aha. So this, the cube root of 81, if I look, 81 is between 64 and 125, which means the actual cube root of it is between 4 and 5. So if I have 6 minus something that's between 4 and 5, I know that this is greater than 0. Out of the 4, it's the only one that's greater than 0. So I know that my min will be negative 2 minus the cube root of 9, and my max will be 6 minus the cube root of 81. And that would be the answer. Just know that you don't have to actually know what these numbers are to figure it out. Now, sometimes they'll be really close and this won't work. Maybe you could have simplified it a little bit more. If you know what the cube root of 3 is approximately equal to, which we could have done, you know, that would be your clue. But you just want to know, is it positive or negative in this case? If you'd had 2 positive, you would have had to have started comparing. Now, this one's going to be pretty small because we knew that 81 is between this these two numbers, so the cube root of 81 is between 4 and 5. Well, 6 minus something between 4 and 5 is not a big number, so, there's hope that maybe you could figure it out that way.